Good morning. Today we're going to take a look at a box that's being pulled across a surface with the box moving across a flat surface but the force being at an angle. In this case, let's examine a problem something like a worker moves a box of materials across a floor by pulling on a strap attached to the box. The worker pulls with a force of 171 newtons at an angle of 27 degrees with the horizontal. The box has a mass of 37.0 kilograms, and the coefficient of kinetic friction between the box and the floor is 0.500. The acceleration due to gravity is 9.81 meters per second squared. What is the acceleration of the box? Okay, so first thing, let's write down our givens. The applied force, which I'm going to label FA, and that's just the force of the worker. FA was 171 newtons, and then it said that it was at an angle of 27 degrees, and so that is inclined at 27 degrees above a line parallel with the horizontal. So theta equals 27 degrees. It says that the mass of the box was 37 kilograms, and that mu k, meaning mu for a moving object, was equal to, I'll tell you what, that mu is bugging me. Let's try one more time. That's a little better. Okay, and so mu k is 0.500. And of course, G, sometimes I'll use 9.8, sometimes I'll use 9.81. Of course, if I'm working for the homework, I always use 9.81 because that's the default. And there we have that. And the question is, what is the acceleration? Acceleration equals question mark. Okay, now before we begin chasing down the acceleration, let's get a free body diagram done and maybe consider then how we want to pursue the acceleration. So, thinking about what other forces are acting on this, let's see. The first one that's always there for us is some type of gravity. So there we've got Fg for gravity. We've got mu k, so we know that there's friction involved. If it's moving to the right, friction has to act opposite that, so friction will be acting to the left. It is pushing against a surface, which means there will be a normal force also. And of course that's perpendicular to the surface, so directly upward in this case. And our applied force is angled, which means I'm going to go ahead and break that into components. And so that would be FAX and FAY. There we go, FAX and FAY. Let's see, let's take a moment and label those. Fg, the force due to gravity. Ff, the force due to friction. Fn, the normal force supplied by the surface. Fa in the y dimension, and Fa in the x dimension. I'll tell you what, while I'm looking at Fa, I think I'll real quickly break that down into, break the values down into the components. And of course, Fa times, let's see, theta is going to be here. So Fa times sine theta will be Fay, since Fay is the opposite side. And Fa cosine theta will equal Fax. Alright, let's see, we'll shorten this up a little bit. He doesn't need that much room to drag things. Alright, let's see. Fa, of course, was 171, and sine 27, Fay, and so Fay will equal, tell you what, we're really trying to squeeze things in there this morning. Fay will equal 77.63 newtons. So 77.63 newtons. That is a 7. So 77.63 newtons. FA cosine theta, 171 cosine 27, and that will be FAX. And so FAX, when I punch that in on my handy-dandy calculator, will give me 152.36. So 152.36 newtons. All right, so there's FAY and FAX. I know that I'll need those, and so I start by breaking up anything that's angled. Let's see. At this point now, we need to look for force relationships and sort of begin working a plan in terms of what we're going to do in order to try and find the acceleration. Now, the way that we're probably going to ultimately find the acceleration is from F net equals m times a. And so that's likely to be our finish line. I'll just go ahead and write that down. Let's think of some other things that are always true, and then we'll look at our x and y. It is always true that Fg equals m times g. It is always true that mu equals ff over fn. Okay, and so I can always write those three things down and not even have to think about it because those are always true. Now, then I need to look at my x dimension and my y dimension, and I need to figure out what's true in which dimension. Okay, so in the x dimension, well, I tell you what, let's start with the y because the y is balanced, which means that the sum of my downward forces is going to equal the sum of my upward forces. Now, upwards I have Fn and I have Fay, so I need to write down Fn plus Fay. The combination of those two is what's balancing out Fg. And in the x dimension, I've got Fax and Ff, but they are not equal because the object is accelerating. And so what I'll have is Fnet equals Fnet equals the large one minus the small one. So Fax minus Ff. Okay, and so here I've got a good plan. I'm ready to start punching in some numbers and see what we can come up with. I'm going to start here with Fg, which is equal to 37 times 9.81. 37 times 9.81 is going to be equal to 362.97. So 362.97 newtons. Okay, so there's Fg. I don't know Fnet yet. I know m, and I'm looking for a, so can't really do any work there. Let's see. Well, I just found Fg, and I know Fay, so that'll lead me over here. So 362.97 equals, definitely running out of space here, Fn plus Fay, which is 77.63. So I'm going to take 362.97 and subtract 77.63 and get 285.34. See, so Fn equals 285.34 newtons. All right, at this point then I say, hey, what could I do with that? Where else is Fn involved? Oh, well, right here next door. And I happen to know mu, so mu times Fn equals Ff. So I'm going to take Fn and multiply by 0.5 because mu is 0.5. So I'll take that answer and say times 0.5 and get 142.67. So let's see, Ff equals 142.67 newtons. Okay, so then I've got FF, and I know FAX, so I'm ready to find FNet. So FNet will equal FAX, which is 152.36, 152.36, and subtract FF. When I do that, FNet is going to be pretty small. It's going to be quite small, in fact. Let's see. So that minus that, and we come up with 9.69. So FNet equals 9.69 newtons. At this point, we're closing in on our quarry. We can smell victory. 9.69 equals 37A. So then take 9.69, divide by 37, and get 0.26 and some change. And so A equals 0.26 units meters per second squared. Of course, if I were doing this for my homework, I would carry that out 2 more spots at least, and so that I would be sure to not lose points for rounding too early. All right, and so that is how we work a question with an object moving with friction across a flat surface but an inclined force. All right, I hope that was helpful, and have a great day.